We're going to start talking about Law 4 and Law 5 today, so I really need you to go ahead and get out 2 highlighters and open up your notes from last class. Last class we talked about Law number 4. So Law number 4, we call this the product of powers. The word product is a the word product means multiplication. The word powers means fancy word for exponents. So I'm taking all of my exponent problems and I'm going to be multiplying them together. So last class we started setting it up, and so if you have this in your notes, you don't have to write it unless you want to. In a couple seconds I'll tell you when you need to start writing. So if I have 3 squared times 3 cubed, I can take 3 squared and expand that out to say 3 times 3. Yes? And I can take 3 cubed and I can expand that to say 3 times 3 times 3. Yes? So now, how many total 3's do I have in the center? Well, I have 5. So that makes 3 to the 5th power. And 3 to the 5th power is 243. Let's look at another one. If I have 5 to the 4th power times 5 to the 6th power, let's expand this out. 5 to the 4th power is 4 5s. 5 to the 6th power is 6 5s. Altogether, how many 5s do I have? 10. 5 to the 10th power is quite a large number. 9,765,625. This is how much money I wish I had in my bank account right now. Let's do one more. Let's do 2 to the 5th power times 2 to the 7th power. Expand it out. 2 to the 5th power makes 5 2's. 2 to the 7th power makes 7 2's. Altogether, I have 12 2's. 2 to the 12th power, 4,096. So, obviously, every time I multiply one exponent problem to another exponent problem, I don't want to have to expand it out to figure out what this is. I want to be able to create a shortcut to get from here to there, and here to there, and here to there. What is that shortcut? Well, that shortcut is all I got to do is add my exponents. 2 plus 3 make 5. 4 plus 6 make 10. 5 plus 7 make 12. So, my rule, add exponents. When multiplication is between the 2 bases, you add your little numbers together. All right, so with this rule, this law, we have 2 requirements. Please make sure these are in your notes. If they're not in your notes, you need to add them. 2 requirements. Requirement 1, multiplication must be between the bases. If multiplication is not between the bases, you are illegally not allowed to add the exponents. Requirement 2, bases must be the same. I am not allowed to add exponents when my bases are not the same. They have to be the same base in order for this rule to work. So let's look at an example. X squared times x to the 6th. Is multiplication between your two bases? Yes. Are your bases the same? Yes. So, add your exponents. I get x to the 8th. Let's look at another one. Let's do 5 squared times 5 cubed. Is multiplication between my bases? Yes. Are my bases the same? Yes. Add them up. 5 to the 5th power. 5 to the 5th power, 3,125. Let's get a little more interesting. What if I had x squared y cubed times x to the 5th y to the 6th? At this point, everybody should be writing all of these practice problems in their notes, so please make sure you are writing them in. So notice x squared y cubed, x to the 5th, y to the 6th. Notice what operations between all of your variables? Multiplication. So, because multiplication is between them, I can group all my x's and group all my y's. And when I group all my x's, I'm allowed to add my exponents of my x's, so x squared and x to the 5th make x to the 7th. And I'm allowed to group together all my y's, y cubed and y to the 6th make y to the 9th. There's nothing else in this problem I'm allowed to do because x and y do not have the same base, so I can't add them together and make xy to the 16th power. It just says x to the 7th, y to the 9th. Let's look at another one. Let's do a squared b cubed c to the 4th, a squared b squared c to the 6th. Notice I put parentheses around this problem. Parentheses just mean multiplication. So group my variables together. Let's do a's first. We always usually go in ABC order. So what operations between everything? Multiplication. So let's add our exponents. I get a to the 4th power. So now look at my b's. I get b to the 5th power. And I get c to the 10th power. Hopefully everybody is with me. Let's look at another one. Let's do L to the 8th power m, that's an 8. M to the 6th power n squared times L to the 4th power m to the 2nd power and n. So why don't you go ahead and pause this video and I want you to try this one on your own. And then we'll go over it. So notice on this one, I have L to the 12th power, m to the 8th power. N is the tricky one. What's my n's exponent? Well, I have an exponent of 2 over here. What's my exponent on that end? Well, it's a 1 because nothing's there. So 2 plus 1 is 3. I know I'm done on this problem because I have no negative exponents, and L, m, and n are only visible once. So now what happens if I involve a negative exponent? Well, ladies and gentlemen, I just add integers. X cubed y squared z times x to the 4th, y to the negative 1, z to the 6th. You always add exponents before you worry about negative exponents. So we're going to do our x's first. So I get x to the 7th. What about y? 2 and negative 1 make positive 1. Z doesn't have an exponent. Let's give it a 1. So I have z to the 7th. If I circle this, I can technically lose 1 point. How come? I technically do not need this 1 right there, so I can go ahead and erase it. What if I had one that looked like this? X to the 6th, y to the 4th, z squared times x squared y z to the negative 6th. Well, I have x to the 8th, y, this has an exponent of 1, y to the 4th, z to the 2 and negative 6 make negative 4. If I circle this, why am I losing points? Because of that negative exponent. So what do negative exponents do? They turn this problem into a fraction. So z has my negative exponent, so it's going down. So I have x to the 8th and y to the 5th on the top, and I have z to the 4th on the bottom. That's a demented looking 4. Goodness gracious, let's try again. There we go. It's still a little demented, but hopefully you're okay with that. Everybody's hanging in there, I hope so. Okay, make sure, if not, you're pausing this video and you're making sure of clarifications. So now what happens when I have coefficients in my problem? If I have 2x squared, I shouldn't be writing in red, sorry. If I have 2x squared times 3x cubed. Notice 2 and 3, they're not part of the exponent. They're not part of the variable with the exponent. 2 and 3 have a different mathy term assigned to them. What is that term that they're assigned to? Well, they are coefficients. So whenever you have coefficients, I call them big numbers in this problem, but whenever you have coefficients, you always multiply those together first. So 3 times 2 makes 6. X squared and x cubed make x to the 5th. I'm not adding 2 and 3 together to make 5. I'm multiplying them because 2 and 3 are not exponents. You only add exponents, which are your little numbers. So whenever you have big numbers, you just treat them like they're normal, and you would multiply them together because multiplication is between them. So let's look at this one. What if I had 6x squared y cubed and 3xy to the 4th? Notice 6 and 3. They're coefficients. What do you do with coefficients? You multiply them. 6 times 3 is 18. X squared and x make x to the 3rd power. Y cubed and y to the 4th make y to the 7th power. I'm done because I have no negative exponents, and x and y are only seen once. All right, my friends, now it's your turn. I'm going to give you a problem. 2x squared y cubed z times 3x squared y to the 4th z to the 5th. Go ahead, pause this video. When you finish this problem, unpause this video, we'll go over it. Notice in your problem you have 2 and 3. What are 2 and 3 classified as? They're classified as coefficients. So what do you do with coefficients? You multiply them. 2 times 3 is 6. You have x to the 4th, y to the 7th, and z to the 6th. You with me? Try this one. Negative 2a squared b cubed times 4a to the 4th b to the negative 1. I lied. Let's do b to the negative 4. Go ahead, pause this video, solve this problem. When you finish it, unpause, we'll go over it. So notice I have negative 2 and 4. Negative 2 and 4 are classified as coefficients. What do you do with coefficients? You multiply them. Negative 2 times 4 is negative 8. I have a to the 6th and b to the negative 1. Can I circle this and be done? Nope. Why not? I got a negative exponent. What has my negative exponent? B. So I got to turn this into a fraction and shift b down. I'm not shifting negative 8 because is negative 8 an exponent? Nope. He's a big number. B to the 1st power. If I circle this, I'm losing a point. How come? I don't need this 1 right there next to b. Hopefully everybody's with me because we are moving on to law number 5. Law 5. This is called quotient of powers. Sorry, my handwriting's terrible on this. Law number 5, quotient of powers. What does quotient mean? Quotient means divide. Powers means exponents. It's a fancy word for exponents. All right. So I'm going to be now, what operation is going to be between my exponents? It's going to be division. And how do we represent division? We use a fraction bar. So let's do x to the 7th over x to the 4th. We're trying to figure out our shortcut. So I can expand out x to the 7th with 7 x's. I can expand out x to the 4th with 4 x's. And in a fraction, 1x on the top cancels out 1x on the bottom. So I can cancel out 1x on the top, 1x on the bottom, 1x on the top, 1x on the bottom, 1x on the top, 1x on the bottom, 1x on the top, 1x on the bottom. Notice I have 3 leftover x's on the top. They can't cancel out with anybody on the bottom. So my answer would be just x cubed. Let's do another one. Let's do y to the 6th over y squared. Y to the 6th power expands to y times y times y times y times y times y. 1, 2, 3, 4, 5, 6. Y squared makes y times y. I can cross out one y at the top and the bottom, one y at the top on the bottom. Who am I left with? Y to the 4th. Now let's do one more. If I have a to the 5th over a to the 8th. Expand this out. A times a times a times a times a. 8 a's on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. Cross out 1a with the top and the bottom. Notice my a's. Where are they left over? They're on the bottom. So a cubed is on the bottom. Who's on the top? 1. So obviously, I don't want to have to do this every time. I want my cheat from here to here, and here to here, and here to there. So what's my cheat? What's my rule? Well, subtract your exponents. 7 minus 4 is 3. 6 minus 2 is 4. 8 minus 5 is 3. So my rule, subtract exponents. So when I'm dividing, when there's division between them, I'm going to subtract the exponents. When there's multiplication between them, I'm going to add the exponents. So we have 3 requirements here. 3 requirements. Requirement 1, bases must be the same and always do big number minus little number. I'm always subtracting my big number from my little number. Requirement 2, if the bigger exponent is on top, then the answer is on top. Requirement 3, if the bigger exponent is on the bottom, the answer is on the bottom. And this will make sense once we get moving. So in my problem, if my bigger exponent's on the top, the answer's on the top. If my bigger exponent's on the bottom, my answer is on the bottom. So alright, let's look at example 1. X to the 6th over x to the 3rd. Notice what operations between your x's? Division. So what are you going to do with your exponents? You're going to subtract them. So look at your exponents. Where's the bigger exponent? On the top of the fraction or on the bottom of the fraction? It's on the top of the fraction. So x ends up on the top of the fraction. So now take your big number minus your little number. 6 minus 3 is 3. Is anybody left on the bottom? No? I'm done. Let's look at another one. Y to the 8th over y to the 4th. I don't want to do 4. Let's do 6. What operations between your y's? Division. What do you do with the exponents? Subtract them. Look at your bigger exponent. Where is it? Top or bottom? What's the 8 is my bigger exponent. That's on the top. So y goes on the top. So now you take your big exponent minus your little exponent. 8 minus 6 is 2. Nobody's left on the bottom. I'm done. Let's look at another one. Let's do x to the 3rd over x to the 11th. Bigger exponent, where is it? It's on the bottom, so x goes on the bottom. So you always do your big number minus your little number. 11 minus 3 is 8. Nobody's left on the top, so who do I put on the top? 1. And I'm done. Let's make it a little more interesting. X to the 6th, y to the 5th, over x to the 10th, y cubed. Same thing when we were multiplying, we only do our variables that are the same. So I'm going to look at my x's first. Where's my bigger x? On the top or on the bottom? My bigger x is on the bottom. Big X minus little x, 4. Now I'm going to look at my y's. Bigger exponent is on the top, so y ends up on the top. Big exponent minus little exponent is 2. And I'm done. You try. A squared b to the 5th, c to the 4th, over a to the 6th, b to the 2nd, c to the 12th. Pause this video, solve this problem. When you're finished, unpause, we'll go over it. A, bigger exponent is on the bottom. The exponent is going to be 4, because 6 minus 2 is 4. Now look at my b's. Bigger exponent is on the top. 5 minus 2 is 3. C, bigger exponent is on the bottom. 12 minus 4 is 8. I'm done. What if I had this? Oops. C to the 6th over c to the 6th. Bigger exponent, where is it? Well, it's nowhere because they're the same. So when they're the same, think about it logically. What's 2 divided by 2? 1. What's x divided by x? 1. So c to the 6th divided by c to the 6th is 1. And here's also another reason as to why. C to the 6th times c to the 6th. Let's just say c ends up in the middle. Subtract your exponents. 6 minus 6. That makes c to the 0. Hey, c to the 0 power equals 1. That's where they developed that rule. So go ahead and try this problem before we add coefficients. Let's do a squared b to the 4th c squared over a to the 8th b c squared. Pause this video. When you finish, unpause. We'll go over it. A, where's it ending up? On the bottom. Exponent is 6. B, bigger exponent is on the top. Exponent is going to be 3. Notice my C's. What do you notice? They're the same exponent, so what happens? They cancel out and make 1. So I'm done. Technically don't need this super long fraction bar anymore. So now what happens if I have coefficients? What happens if I have 6x squared y cubed over 12x to the 4th y. Well, when we had coefficients when we were multiplying, what did we do before? We multiplied our coefficients. So when we have coefficients when we're dividing, we just simplify. And if you don't want to simplify in your head, your calculator has this fabulous tool that does it for you. So, in your calculator, 6 divided by 12, enter. Math, enter, enter. You get 1 over 2. It is always good to use the math, enter, enter trick so you don't accidentally make boo-boos and get these wrong. Always, always, always check your work. Look at your x's, where they're ending up. Bottom. Exponent is 2. Look at your y's, where are they ending up? Top. Exponent is 2. Technically, I don't need this 1 here. I'm done. What if I have this? I have 4a squared b 6th c over 22a to the 4th b squared c. So, first thing I always do, my coefficients. 4 over 22 in my calculator, math, enter, enter, I get 2 over 11. Look at my a's, where are they ending up? Bottom, exponent is 2. Look at my b's, where are they ending up? Top, exponent is 4. Look at my c's, what happens? They're the same, they cancel out, I'm done. You with me? What if I have this? Whew, this is a mess. Let's see what we can clean up. Cx squared, y to the 0, c to the negative 2, all over 10x to the 4th, y, c squared. Looking at this problem, what's the best thing that I see in this whole problem? Y to the 0 power, because it equals 1, so it's gone. What's the next thing that I notice? I see a negative exponent, and you really don't want to have to divide negative exponents. So whenever you have a fraction with a negative exponent, you always want to move it. Negative exponent's going to go down. So I'm going to have 6x squared over 10x to the 4th y, c squared, because this c squared I just moved down. So now I'm going to clean some stuff up. 6 over 10, type that in my calculator. Math, enter, enter, I get 3 over 5. Look at my x's. They're on opposite sides. Where are they ending up? The bottom. Exponent is 2. Notice y. Does y have anybody to work with? Nope. So he stays on the bottom. Now notice your c's are on the same side. So notice what operation is between your c's? Multiplication. So you're going to add your exponents, you're going to subtract your exponents. Well, since multiplication's between them, I'm going to add them, and I get 4. I'm done. So let's make this a little bit more interesting. 2x squared y cubed z over 3x cubed y squared z squared all over 18x to the 5th y squared z to the 6th. Oh boy, that's a mess. Whenever you have a problem like this, you always clean up the top and divide last. You clean up the top, you clean up the bottom, you divide last. So right now, I am only going to focus on cleaning up the top. So if I were to clean up the top, what operations between everything on the top? Well, multiplication. So since multiplication's between everything on the top, what are you going to do with your exponents? Well, I'm going to add them. But what am I going to do with 2 and 3? Because those aren't exponents, those are coefficients. 2 and 3 get multiplied together to make 6. So you have x to the 5th, y to the 5th, z to the 3rd. Because multiplication was between all of my problems in the top, I added my exponents. All over 18x to the 5th, y squared, z to the 6th. My bottom's already cleaned up, so I'm good to divide. So let's do coefficients. 6 over 18, math, enter, enter, 1 over 3. It's always good to double check in case you're accidentally wrong. Notice your x's, what happens? They cancel out. Y, where does it end up? Top, exponent is 3. Z, where does it end up? Bottom, exponent is 3. Technically, I do not need this one, so I can erase it, and I'm done. Let's do another one. 5a squared b cubed c cubed times 2a cubed b to the negative 2c all over 2a to the 5th b squared c to the 7th. So on a problem like this, what am I going to do first? Clean up that top. What do I do with my big numbers? Multiply them. What do I do with my exponents? Add them. A to the 5th, b to the 1st, c to the 4th. All over 2a to the 5th, b squared, c to the 7th. Am I done? No, I got a's, b's, and c's everywhere. Let's clean it up. Coefficients first, please. What's 10 over 2? 5. So since 5 is a whole number, it always goes on the top. My a's cancel out. B ends up on the bottom with an exponent of 1 because 2 minus 1 is 1. C ends up on the bottom. Exponent is 3 because 7 minus 4 is 3. And I'm done. Hopefully you're all with me and hanging in there. Let's do one more. One more. 6x squared y cubed z times 3xyz all to the 0 power all over 2x cubed y to the negative 4 z all over 20x to the 6th y to the 8th z. You need to pause this video. I want you to attempt this problem on your own. I wish you the best of luck. Alright, let's take a look at it. What's the best piece of this problem? This whole middle parenthesis is raised to the 0 power. So that whole middle parenthesis just equals 1. It's gone. So what do I do with the other ones? Multiply the big numbers, add the little numbers. 6 times 2 is 12. I have x to the 5th, y to the negative 1, z squared. All over 20x to the 6th, y to the 8th, z. Technically, I would not divide yet because the top is not cleaned up as the way that it could be. I have a negative exponent. I would move that down first. So 12x to the 5th, z squared, all over 20x to the 6th, y to the 8th, z, y. So now I can clean stuff up. 12 over 20. 4 goes into both, or I can do math, enter, enter. I get 3 over 5. X ends up on the bottom with an exponent of 1. My y's are on the same side, so when they're on the same side, I add them. I get y to the 9th. And z ends up on the top with an exponent of 1, so I don't need to write it, but I can erase my fraction bar a little bit, and I'm done. Your homework looks a lot like these types of problems, but we're going to keep practicing if there's still time in class.